Danny.
I'm Pablo.
I'm Alejandro.
We're all in Year 10
At King's College International School.
Madrid, Spain.
King's College Sota Vinuelas Madrid is a co-educational British curriculum day and boarding school with nearly 2,000 students from pre-nursery to year 13. In this experiment, we will be making liposomes. First, some background. The cell membrane controls the movement of substances into and out of cells. It is mainly composed of fats called phospholipids. As well as being flat membranes, phospholipids can be engineered to curl up at the edges and self-close, forming tiny microscopic bubbles called liposomes. Liposomes can be loaded up with medicines. They can then deliver a medicinal drug to a specific target within the body, such as targeting anti-cancer treatments directly to a cancer tumour. In this experiment, we will be making liposomes using phospholipid extracted from egg yolk. Here are the materials and equipment we're going to use.
First, we weigh out the phospholipid and dissolve it in chloroform.
Now we use the rotary evaporator. Using a vacuum, an increased temperature of 50 degrees, and rotation, the dissolved chloroform is gently evaporated, leaving behind a thin dried film of phospholipid. The film can be seen on the surface of the flask.
Next, we rehydrate the lipid film by adding heated buffer. The buffer contains a dye, methylene blue.
We shake the flask hard.
The shaking causes the lipid film to detach from the glass. The lipids get pulled off and self-close to form tiny spheres, liposomes. As the liposomes close up, some of the dye gets trapped within the inner core. This is also how medicines can become incorporated within liposomes.
But not all the methylene blue is entrapped within the liposome. To remove any excess dye, we use a centrifuge. We transfer our liposomes to the centrifuge tubes. The centrifuge spins the samples round at high speed.
The liposomes are spun to the bottom as a pellet.
The top layer is then decanted. This ensures all the excess dye is poured off.
Now we add fresh buffer with no dye to the pellet. This allows us to prepare a slide. A look under the microscope? Liposomes!